Can you hear me? Divine? Okay. I think Divine is muted. I was asking everyone at the beginning of the class if they've gone through the assessment and they've been able to do it. So I just wanted to hear from Divine. Well, notwithstanding, I will just dive into today's class, but our usual theme is for us to discuss some of the things we've discussed from the previous class. Oh, you said you're having issues with your microphone. Okay, no problem. One of the things we do is we are always discussing what we've enjoyed from the previous class. So is there anyone here willing to give us more like an overview of what we discussed yesterday? Anyone? No one can give us the overview of what we discussed yesterday. Okay, let's hear from you, Silvanus.
Yes, so yesterday we were discussing about the tempo and referencing. And we discussed that tempo is a compound of various data types. You can put strings, assigned or assigned integers. You can put a variety of data when you're doing a tempo. Then when referencing, I'm still confused about referencing.
Great. I'm happy you made mention of one thing we did, which is tuples. It's a compound data type, and you made mention of that. Great. Then you made mention of referencing. Don't worry, in today's class, we are still going to touch referencing as we are going to talk about ownership in general. So, but can anyone tell me what he understands by ownership in Rust and what we discussed about it from yesterday's class? Anyone? Is everyone saying they didn't understand reference? Is it that everyone didn't understand reference and ownership?
I think they very much.
Edrin. You can unmute and speak. Please tell us. Remind us of what you understood from ownership and referencing. You can unmute. Is Edrin with us?
Yes, I'm with you guys. Good evening.
Yeah.
Good evening. Good evening. Is anyone hearing me?
Yes, we can hear you. Good evening.
Good evening.
Yeah.
Good evening. Yeah.
Anyway, yesterday we discussed about ownership, referencing, and borrowing. So I want to just talk about ownership. So, like I discussed yesterday that the very advantage of Rust is that it allows us to own our code. I forgot it. Yes, ownership allows us. I forgotten. I forgotten.
Yeah. What I appreciate you for still trying. I appreciate you for still trying. How come apart from Edrin and Silvanus, is there anyone that is going to tell us what ownership is? I mean, we can't proceed to talking about functions if we don't have full understanding of what ownership, reference, and borrowing is based on what we discussed from the previous class. Are we saying we didn't get it? I want to hear comments. Whether you understand or not, I want you to raise your hand and just tell me if you understand. If you don't understand, should we go back to it? I want to hear someone say something. Okay, let's hear from Tez. Oh, wait, before Tez, let's hear from you, Von, please. Then we hear from Tez. Yes.
Okay, so when it comes to ownership, we mentioned that with verse, each value have its own ownership. And so it's all about the ability of for a variable to have its own ownerships. And ownership is a unique model, and it can be borrowed when it comes to the borrowing function in order to make a good references. So yeah.
Thank you. Thank you very much, Yvonne. I appreciate hearing that. Tez, let's hear from you, please.
Yeah, so what I got, the most important thing was that so variables you can allocate, that ownership means it gets space and memory. So to save space,
I don't know
to
if
make your
it's my
code
network or you're breaking, Tez. I don't know if it's from my end. Can someone else confirm? They can hear Tez clearly. So I'm sure it's not from my end.
Yeah, his network is breaking.
Is it better now?
Okay, yeah, it's better
Is it
now.
better now?
Yeah, it's better
Okay.
now.
Yeah, so I was saying that the ownership conversation for me, the important part was that you could get assigned when a value gets ownership, that value gets committed to memory. So to get to save memory and to make your code maybe faster, you can make reference instead of having two variables with the same value that will commit double the space in the memory. You can just reference the second one to the first one, for example. And also within, so when you assign within the scope as well, how the value can get assigned within scope and out of scope, and how that also can save memory, and how the value moves between in scope and out of scope. I found that interesting as well, that you can create, for instance, maybe for loops or arrays, and then to save memory you can also use that referencing trick as well, instead of committing everything to memory and making your code slow. So that for me was the main highlights.
Thank you very much. Thank you very much. Thank you very much. I'm happy to hear that. Adrian, you have something to say?
Yes. After who was it? Talking, I remembered Tez. So I'm just going to give an example to make a clear understanding of what we discussed about ownership. Like yesterday, you were showing us how like you gave us like an example of, let's say we have a variable s that is storing a string. Let me say it's storing a string name, which was your name. So if at that point s is owning that string, then if another let me say you want to borrow it, you could borrow it, but the ownership is on S. Okay, I don't know. I would use an example of a line of code, but I think that would make it clear. But basically, it is like if we declare a string or any variable, the first declaration is owning it, then the rest of the declarations are going to just be borrowing using the other kind of placeholder sign of and. Yeah.
Thank you so much, Adrian.
Right.
Tess, Adrian, Yvonne, Sylvanos, and every other person that have answered. I really appreciate every single one of you. Thank you so much for your answers. But I'm going to take a census based on this ownership model and referencing borrowing. I want everyone to raise their hands up if they feel we should take ownership over again before moving to functions. Because based on my review or what I'm saying, it feels the ownership understanding is not so much. So you can just raise your hands up if you feel I should take the ownership model again before moving on to functions. Okay. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wow, that looks like a tie. We have 12 people raising their hands. Okay, apart from me, okay, I won't count myself. So definitely we should take it over again. We should take it over again. So this counts that, okay, we have majority. Currently the class is 24. Okay, so everyone can drop their hands. So basically we'll be taking the ownership model again, and that means I'll stop sharing functions and rather we would go back to ownership. Now, the reason why I'm saying this is, yeah, you can drop your hands, Joyce. The reason why I'm saying this is what we want to achieve at the end of this semester is understanding, not speed. And that's why I like hearing what everyone understands and like hearing if we should proceed or take the topic again. Now, in all honesty and truth, ownership model is in fact a completely different model when it comes to programming languages. So many programming languages do not make use of this model, and that is quite understandable. And so even for previous developers that have been writing code for years, when they come to starting to write Rust programming language and they start learning about, this kind of model, it feels strange to them. So that's understandable compared to someone that's completely starting for the first time. So yeah, that makes sense. So what this means is that we are basically going to, go back to the previous lecture, and then we will take ownership all again. So I'm going to share my screen and we are going to explain ownership from the code all over again. So yeah. I'm going to close. I'm going to comment all of this. I think I should I'm going to comment all of this. I'm going to comment it. And we are going to start from scratch. I'm going to also comment. In fact, I will remove this. This was while I was explaining to someone yesterday on the class. Okay, so now we are on a clean slate. Let's start from here. We are on a clean slate talking about ownership. Ownership and borrowing. Good. Now, when we talk about ownership, what we are talking about is that every single variable inside that is declared inside of the Rust programming language, I mean, every single value that is declared inside of a Rust programming language is always owned by just one person. What do I mean by this? I'm not going to use string for this example. I'm going to use a simple number. Now, let's look at this number. Let's say x is equal to 10. What are we trying to say in this case? We are trying to say that this particular value, 10, is owned by x That's what we are trying to say basically. This particular value is owned by X. So that means that anytime this particular value is passed on to another variable, this variable X is no longer the owner of this value 10. For example, let's say we create a variable Y and then we say Y is equal to X. At this particular point, it means that X is no longer the owner of variable 10, of value 10, I mean. Rather, Y is the new owner of value 10. That is, the ownership of this value has been moved from X to Y. How do we know this? Let's try to consume X. For example, a simple way to consume X would be us printing it at this particular point. Oh, let me use string instead, please. Yeah. So at this particular point, the value of X is now owned because it has been moved to Y. So that means that X no longer contains any value because X has had its value moved to Y. Are we getting it? Is there any question at this particular point? Okay. Okay. So what does it mean to now borrow? Borrowing means that on the memory, instead of us to completely clone and have this in two places, if we use .clone is literally a method on this struct string. Instead of us to have this particular value Ayomide in two places in the memory, we can do something. What is that thing? We can borrow. How do we borrow? We borrow by using this sign. So by using this sign, we have borrowed X, but rather we have not moved the ownership of X to Y. So that means at this particular line 72, the original owner of value Ayomide is still X. So moving on to line 72, then the value Ayomide has been borrowed from X. So at this particular point, this is a reference to this. So that means that at this point, if we keep saying Z, for example, let's say Z is equal to this, Y. Okay, you can unmute and ask, please.
Sorry, man. I'm not sure if maybe it's on my end, but I never got that because the network on your end. I'm not sure. Do you mind just saying that again, please?
No problem. But is that the same for everyone? Is there a break in the network from my end? Just to be sure.
No, we are hearing you clearly.
Okay, okay. Okay, I'll go back and explain that again. Now, I made mention that at every single point in time, when you declare a dynamic variable, this is a dynamic value. So this particular dynamic value is in the memory. Now, this dynamic value in the memory is owned by X, which is the variable name. Now, I mentioned that it is impossible, let me comment this out. It is impossible for two different variables to own one value. What am I saying? It is impossible for X and Y to own the same value. Now, in other languages like JavaScript, like Python, you can declare one variable and then that one variable, you can keep assigning it to other variables, and other variables would definitely have access and claim that value as if it is their own value. But that is completely different in Rust. In Rust, each value has just one owner. And that is exactly why we have this compiler error. We are trying to consume the variable x, but then the value of x has already been moved to y. And for this reason, we cannot consume it. We cannot use it. For example, I'm just using print clean to, to print it to the console. What if we want to do something else like let z equals x plus 2? Oh, this is even a problem already. You can't do this. Let's use clone, for example. You cannot do this because I'm trying to clone x, but then x value has been moved to y. And for this very reason, x no longer has a value. So the ownership of this value, Ayomide, has been moved to y. So the only way we can now have access to that value, another way we can have access to that value without completely taking over that value, is through what we call borrowing. What does borrowing means? It is literally creating reference, and you create reference with this sign. And so when you create this reference, at this particular point, this particular dynamic value is no longer what? It is no longer moved. Instead, it is borrowed because a reference has been created pointing to this value in memory. So now you can keep on borrowing and borrowing and borrowing. Now notice that this particular y is borrowing from here. Now z is now borrowing from x. Z is borrowing from y. So that means that at this particular point, z is a reference of a reference to x. So for example, imagine I do something like this. Let p equals x. What happens? We cannot do this. Why? Look at the error. Cannot move out of x because it is borrowed. So that means that the moment a particular variable is being borrowed, now you cannot move that value out of the variable that is being borrowed. Now, this is another rule. You cannot move that value out of the variable that is being borrowed because it is already being borrowed by another variable. At this particular line 72, y is borrowing x at that point. Now, while y is borrowing x, I tried to move the value of x into p. Notice that on line 72, y is still borrowing x. But then x would have a problem to moving because it has been binded. Y has been binded to x. And so x cannot now move the ownership. But then there's a question. Edrin.
Well, can I first see the screen? I wanted to refer to yeah. So according to what you're saying on line 72, y has borrowed x, then you had put a certain line of let p equal to x, and we have a compile error. So as of now, but then what if we say let p equal to y? Will it still have the error, or like the fact that right now y is done with that borrowed x to?
Let me take this out of school. Why do you think we don't have an error? Let me ask you. Why do you think we don't have an error?
Well, I think I was just thinking that the fact that y at the moment then that has borrowed x, so x is referencing. Sorry, y is it can print the what? It right now it's y that prints that is storing the string Ayomide. So if we are letting p to be equal to y, I think that will be okay because at the point y is then that is holding the string Ayomide.
Well, the answer to that is that because at this particular point, y is referencing to x, and y is not the owner of the value Ayomide. That's why it can move it. So at this particular point, the referenced value of y has been moved to p. So let's say we want to print y now. Would we have an error? Let me use y. Would we have an error? No. Why wouldn't we have an error? This is because at the end of the day, y is just a reference. Y is not the main owner. Y is not the main owner of the value, Ayomide. Rather, y is just a reference. And because y is just a reference, it means that y can, be cloned and it can be moved from one variable to another, and it will still reference to the original owner of the variable, of the value, I mean. And in that particular point, the original owner is x. So no matter what happens at all these points, x, as long as the real owner of it does not move the value into another place, notice all of them are linked to x. All of them are borrowing from x. But the moment I do this, I say x, let's use another, let's say u is equal to x. When I say u is equal to x, what happens? Problem. We have problem here. If I comment this, we have problem every other places. That's because at this particular point, this y is now trying to reference a particular variable that no longer have a value. So that is ownership and borrowing. Now, this ownership and borrowing that I've just explained is on the basic level. As time goes on, we will see how important it is that we make use of this ownership and why ownership and borrowing is very important. In fact, one of the reasons why it's very important is that when you are declaring a variable, you don't waste memory. What does that mean? Now, your programming languages, eventually, what happens is that it is compiled down to matching language. In this case, it is compiled down to WASM. So what is WASM? WASM is a closer language to machine language. While it is compiled down to WASM, it's also compiled down to binary. What is binary? 0 and 1. And now this is what computer understands. Now, why computer understands 0 and 1? It is now easy to allocate this memory and ensure that the amount of memory your computer is using for a particular program you are running is not unnecessary. What do I mean by that? Notice that this particular value is taking up a dynamic sized memory. It is a dynamic sized data type in the memory. So now we don't want to continue creating so many dynamic sized data type in the memory, because at that particular point, it now starts eating up the memory of your machine. So that is why this particular ownership model now helps you to reference to a particular value instead of repeating that memory and creating that original value all over again. And for this reason, it makes your program run very, very fast. That is one of the reasons why people love Rust programming language, because for one thing, this particular ownership model allows you to write code that are very efficient. So imagine you are writing this particular type of code, exact code you are writing. Imagine you are writing it in Python. Now for Python, it is already taking up another memory entirely. When you do this same thing I'm doing, because there's no ownership and borrowing model, it's already taking this memory all over again, a dynamic sized memory all over again. Now imagine that kind of program. You write a program in Rust, you write the same program in Python. Which one will be faster? Rust. That's because it is not taking so much memory like it is taking in a different programming language like Python, because unnecessary memory usage is being avoided. And this is one of the beautiful things of ownership and borrowing. Does anyone have any question at this point based on what we have just explained on borrowing and ownership? Anyone have any question? Okay, can we get thumbs up to proceed to ensure everyone is following up? Okay, great, great, great. So this is why ownership is important. Now, as we proceeded yesterday, from yesterday's class, I mentioned that there are certain situations whereby a value, when it is owned, it can go out of scope. For example, let me uncomment the example I did yesterday, this. Now, this was the example I did yesterday. Now, I mentioned that this is a situation where we have a scope. And I'm happy that from some of the explanation that some gave when they were talking about what I explained yesterday on this ownership and borrowing model, they were able to even point out to other type of scope like for loop, like if-else statements, like even a function. All of these, as long as you see these curly braces, it is a scope. Now, inside of this scope, we can even create another scope inside of this scope. Can you see where this one will be here? Can you see? Now, why do we have this error? We have this error because this car is now trying to reference what is not in its own scope. That is where we started talking about a value, the ownership of a value going out of the scope. So now let's comment this and do something else entirely when it comes to scope. So let's go down. Now, we are going to use example of cars like I did yesterday, but I don't know. I don't think I want to use Toyota. I use Toyota. I guess I'm still told to use Toyota. Okay, let's use Toyota. So now we have Toyota. This particular variable car has a value called Toyota. Now, Toyota is owned by car, by this variable. It has just one owner. But then, imagine Toyota is inside a scope. Let's say Toyota is inside this particular scope. Is it possible to still borrow from Toyota outside of the scope? That is it possible to borrow from this variable car outside of the scope? Let's try it. So let's say car 1 is equal to, we are trying to reference car, right? Is it possible? No. Why is that? This is because the car we are trying to reference is not in the same scope as the particular new variable we are creating, which is car 1. It is in a different scope. Now, how this works is that we have a global scope, inner scope, and we can keep creating scope inner like that. So what this means is that a particular variable outside the scope of another scope can be called or used inside of another scope. So what does this mean? I'm going to comment this, and I'm going to create another scope for us to see what I'm talking about. Now, let's say we have let car equals, let's still use our Toyota. Now we have a scope. Inside of this scope, we say let car1 equals reference to car. And then inside of this scope, we can go down to now say let car2 equals car1. At this particular point, we can go down, create another scope. We say let car3 equals reference of car1 of car2. Although at this point, we already understand that car2 at this point is a reference of a reference of a reference of car. That's why we have these three reference sign here, because it's a reference of a reference of a reference of a reference. But then from yesterday's class, I explained how we can dereference it, where we say car4 is now equal to the reference car3. At this particular point, notice that the reference is now 2. So the reference from 2 now means we are referencing car2 here. Car4 is now referencing directly car2 here. So on and on and on like that. But then that's not the point of this scope we are talking about. What's the point of this scope? The point of this scope is that every variable inside of a scope can have access to the variable outside of that scope. For example, car itself is in the global scope, but then car1 have access to car that is in the global scope. Car2 is inside, let's call this one scope 2. It's inside an inner scope than car1. Car2 can still have access to what? To car1. But then imagine we now come down and say, you know, this particular scope is still car2 scope. So let's say we now say let car4 equals reference of car3. What happens? We have a problem. Why do we have a problem? This is because at this particular point, car4 is trying to reference car3, which is inside an inner scope. So that means that when you declare a variable, if the variable is outside a scope, the scope inside can reference or can have access to this variable. But the moment that particular variable goes out of that scope, the variable is automatically dropped and it no longer have access to it. So now if we come down and we check out of this scope and we say, let car5 equals reference, let's use reference of car4. Do we have a problem? Yes, we would have a problem. But then imagine we said, let car5 equals reference of car. Would we have a problem? No. Why? This is because car5 is in the same scope as car. Also, this can keep going inside. Sorry. This can keep going inside of the scope. We won't have a problem. We won't have a problem. Even it can keep going inside of the scope. That's because car is the one that is outside of the scope. So that is basically it. Does everyone understand scope referencing of variables in a scope? Okay. Okay, great. Now, from what we have just explained, I think we've basically used today's class to talk about this referencing, borrowing, and ownership. So at this particular point, is there anything from this particular idea a person does not understand when it comes to referencing and borrowing? You can raise your hand now so that from tomorrow's class, no one would have any problem. We'll be sure that we have covered referencing and borrowing. This silence, I take this silence as that everyone now totally understand referencing and borrowing. Having that in mind, we will then proceed to what we were meant to do in today's class, functions. Now, what is a function? A function is a block of code designed to perform a specific task. It's basically makes sense. That is, a particular block of code you have to perform a specific thing. Now, a function can do more than one thing at a time, but at the end of the day, it's just for it to do something. So you can think of function as garbage in and garbage out, input and output. So you can create a function that can do something for you. A function is basically a bunch of code that you create to perform something, to do something for you. So now, another reason why we create function is it's for reusability. Now, when you start writing code, notice that everything we have been doing here is been so scattered. What's the point of this particular line of code against this particular line of code against this? Everything is gibberish, although that is because we are trying to explain a particular model. But then, what does function does? Function help us to arrange our code in a way that we can organize it, and organizing it means you can now use a particular function for something. You can use a particular function for something. So now, what does a function look like? Let's move to that. This is what a function looks like. A function has the keyword fn, followed by the name of the function, the parameters of the function, and then the return type. Now, it's not all functions that basically have a return type. Some functions, it can be created without having return types. It's based on what you are using the function for. And then you have your curly braces and the code inside of it. So that is basically what a function is. Now, you can think of function as a machine. I think I like using that as a machine. You can think of function as probably a microwave. You can think of function as a freezer. The function of your freezer is to freeze your item, whatever you put inside of it. That's the function of your freezer. Your freezer would not do the work of your microwave. Your microwave has its own function. The function of the microwave is to heat up any food or anything you put into the microwave. That is the function. So you can think of that as the same definition of a function. A function takes in an input and it gives you an output, or it performs an action. So just like your microwave will take in your food or your item and it performs an action on it, an action like increasing the temperature of that particular food or item. That is the same thing a function does. And it's important that you now organize it. Imagine we had our freezer, and our freezer, inside of our freezer, we have our microwave doing the same thing inside of our freezer. And inside of the microwave, we have a television inside of it that is also displaying inside of the same freezer. Everything is happening there. That would be a problem. So that is why all of these particular actions are being grouped using different functions. And that's the same way function is. So you can have a bunch of code that does series of things. And so those series of things can be modularized into functions, having each of these functions perform a separate action. Now, functions are also used for reusability. Now, you can create a function that you would use to do something else. That is, you can use this function to call another function calls that function. So you don't have to write a particular stuff over and over and over and over and over again. So that's basically what a function is. Now let's go into our code and look at example of a function. I'm going to use this as an example, but I'll type it out myself. Let's have this function that says function hello. Now, this particular function what it does is the action I want function LO to do is for function LO to print hello world for me. For that reason, I'm going to print hello world. Hello world. So now, this particular main is where all this function is being executed. So I'm going to call this particular hello here. So I'm going to say hello, and I'm going to call the function. Yeah, let me remove this. I think we've had that class passed. So now if I cargo run this, we are going to have what? We are going to have hello world. Can we see it? Hello world. Now remember that I said that a function can be reused over and over and over again. That's one of the use of a function, reusability. Look at it. We can still keep typing hello here. And inside of this hello, we'll type another hello. Sorry. And now, when we cargo run this, how many hello words do we have? We have 1, 2, 3. Reusable. Now, the function of this hello is to perform a single action, is to print hello words to the console for me. And so I can keep calling hello over and over and over. Now, after creating a function, the way to call that function is to write the name of the function and add 2 parentheses at the back of that function, like you can see me do here. Now, notice properties of this particular function I wrote here. First of all, we have the keyword, we have the name of the function, we have parentheses, but inside of these parentheses, we did not add any parameter to the parentheses. So this particular function is not taking anything here, as we can see. There are no arguments that are being passed in because there is no parameter created for the function. So this is followed by the next thing. Now, this particular function does not return anything. So for that reason, we are not using this particular sign or a return value to it. No, we are not. We are not adding that. And as time goes on, I'm going to show us why that particular return value is even showing a compile error. As time goes on, we are going to know why. But at this particular point, this is what a function looks like and how to call a function. So let's proceed to our slide. Components, anatomy of a function. We have the name, like I made mention of, the parameters, which are the inputs to the function. We have the body, which is the block of code, and then the return type. So now this particular example gives us example of what a function looks like. In this case, we have a particular function that does something. So let's think of an example. Let's not use the example we have here. Remember, we said functions are used to perform certain action. Now, let's, for example, we want to make life easier. And we want to create something that calculates area of a square and perimeter of a square for us. So let's create 2 functions that does this for us. So we have, now notice that when I comment this, there's a problem here because I've commented this. So I'll just comment them too. So let's say we want to create area and perimeter of a square or a rectangle. So based on our, I don't know, junior mathematics or elementary mathematics, we know that area of a rectangle is length times breadth, Abby. Is length times breadth. That's for area. Let me put that like this. Now we know that perimeter of a rectangle is 2 times length plus breadth, right? So now what we want to do is we want to create 2 functions that makes life easier for us. What the function does, the first function does is whenever we pass in our input to it, that is, we will pass in our length and our breadth to it, we want that function to always calculate area for us. Whenever we pass in the length and breadth into the other function, we want that particular function to calculate the perimeter of any rectangle we pass it to us. So without us having to sit down and think of doing this, we want to create a function that performs this action. So the first one we are creating is area. So we are going to create it. We name the function area. Now, for the area, it's going to take length, and for the length, the type of the length is a floating F32. Let's use F32. Then for the breadth, let's also use F32. And so in this case, we are using what we call a return value. The return value, we want it to be F32. So now, how do we do this? We can say let area A equals what? Length times breadth. And then what do we want to do next? We want to return A. So right now, what we have done is we have created a function area for it to help us calculate length times breadth. So every time you pass length and breadth to this particular function, it should calculate it. It should always calculate it. Now, this particular function I created is when you think of it in the real programming sense, it's an overkill. There are so many unnecessary things we added to this function that we should not have added. So let's try to refactor it. Why am I refactoring it from now? I'm refactoring it from now because I want you to have a vivid understanding of what the right, what do they call it? The right programming practice is. And so for that reason, I'm going to create this function area1, and it's going to have the same input, which is F32, and it's going to have breadth, which is also F32, and it's also going to return F32. But this time, what will it do? We will just say length times breadth, and that's all. So what's the difference between this first function and this second function? We notice that for the first function, we first of all multiplied length and breadth, and we kept it inside a variable A, and then we returned that variable A. And while returning the return variable A, we even used the return keyword, and we used the semicolon. Now notice that in the second function, all we did was we just said length times breadth. What does this mean? This means that this just takes us how many lines of code? Just 3 lines of code. This one takes us 4 lines of code with additional, coding to it. We don't need to do that. So this is the right coding practice. Why? As you can see, this return keyword is not necessary if you are not adding the semicolon at the back. So you can basically return a value by either using the return keyword or you are adding semicolon at the back. So now I'm going to take away this particular function as I want us to use the best coding practice. But I just want to show, for those coming from a different programming background, you might just notice, why is there no return keyword there? For that very reason, that's why I also demonstrated that. So for this one, how do we calculate it? Let's quickly also create our function perimeter. And our perimeter would also take length, which is F32, and the breadth, which is also F32. And then it should return an F32. And in the F32, we want it to be 2 times the length plus the breadth. So we have this. Can someone from the class tell me why we have this compiler error under this multiplication sign? This is to test our previous knowledge. Keyboard, please. Sorry, you are not clear, Keyboard. Okay. Okay. Let's hear from Silvanus.
I think it's because it's outside the scope. It's on the global scope.
No, that's not the reason. But thank you very much for that try. Thank you very much. Edrin.
The reason I saw we are getting a compile error is because 2 is an integer and we are multiplying it by L by the length. So we are adding it with a floating point. So
Thank you very much. That's the correct answer. What we have here is a data type floats 32, which is a decimal. But what we are trying to multiply it by here is an integer. So the data type is completely different. And so for that reason, it's going to throw a compiler error. So for this, we have to add times 0.2, times 2.0. And so adding 2 or 0 at the back of this 2 will make it a floating point too. And for this reason, we have a compiler error. And with this, we are done with the 2 functions we want to create. What are the uses of these 2 functions? This one is to calculate area of any rectangle. This one is to calculate perimeter of any rectangle. So we can come to our main, and then let's say length equals, let's say the length of our rectangle equals 10 centimeters. Let the breadth of that rectangle equals 20 centimeters. Now, we can say the area, let A equals what? The area, which is, it can now take in length and the breadth. You know what? I think I will just write this out well. When one of the good programming practice is for you to always write it out in full. So I'm just going to write it out in full. Why you do this most times is so it's easier for you to remember. So for this, we can say this. And then we can basically print this. Print this. Let's name this one area 2. Perimeter. So we are going to name this perimeter, and then we are going to print this. The area is this, and the perimeter is this. So we have the area and the perimeter. So when we cargo run, what happens? Can you see? The area is 200 and the perimeter is what? Is 60. So every time we can come here and keep creating, let's another area. Let's name it another area equals area. And then we can even put something else here. We can say 82.2. This one could be 990, whatever point this. And then we calculate it. Oh, expected functions found F32. Okay, that's because we named, this is clashing with this. You see why it's important that you are careful with your variable. So let's call this res, which is response, and then we change it here. And so at this particular point, you can print this also out, and then let's paste this here. And then at this point, if we can go run it, we have our area. Can you see it here? The area is 7063827. Can you see? So this particular function, we can now use it for anything. We can keep using it over and over and over and over. Imagine you want to create a simple application that what it does, it calculates area perimeter of a rectangle. With this, you have literally created that simple software that does that. And anybody that comes can keep passing in the values and all of that. And then you create a beautiful user interface to it. But behind the scope, this is what is happening at the background. So this is an example and use of a function. Notice that this particular function area is not doing the job of a perimeter. It is doing the exact job it is asked to do, which is to calculate the area of a rectangle for us. So that is that on functions. So from our next class, we're going to continue more on functions. We're going to understand ownership and borrowing, where a function takes up the owner of a particular variable. When does that happen? All of this, we are going to enjoy it from our class tomorrow. So at this very point, I'll stop sharing and I'll stop the recording. And at this point,